4, 3, 2, 1. I'm John Miglosh for the WDMA and the International Society for Strategic Marketing. Today we're going to do a bit of a reprise on my speech that I'm giving, a quick overview summary, and so let's dive right in. What I'm talking about today is the foundation of machine learning, and that's a hot topic. Everybody's talking about AI in marketing, and what are they saying? Well, they're saying, got to get over here to the proper slides. They're saying that there are challenges, but any minute now we'll be able to solve it. Now, I have a book that's this thick about the AI bubble in the 1980s, and it's so fun reading because they're talking about what machines will be doing any minute now, and everybody was investing and the whole thing collapsed. So let's take the hubris with a bit of a grain of salt. But what is marketing after? I looked up in the machine learning in the actual sites, and I'm going to give you all the references today. But they're looking at improving understanding of customers. Now, that is a little bit funny because we're asking a machine to understand something that we don't understand about our own selves. When people talk about customer journey, I ask them what theirs is. They can't tell me. The check engine light came on, so they went and bought a car. Retaining customers. Okay, yeah, and read my book, The I Love You Variable. The geodemographic, psychographic differences between your best customers and your so-so customers are almost insignificant. But some customers love you. And try to model that, and you're going to be exposed to frustration. But anyway, the bottom line is everybody's looking for how do we get this machine learning to work? Machine learning goals, marketing is a high priority target. In fact, now the software vendors are targeting the CMO rather than the CIO or the head of IT, probably because he's a bigger sucker. My dad used to always say, salesmen are the easiest to sell to. Anyway, who knows? Anyway, so, and they've got, they just have this insatiable thirst for more data. And why is that? Well, that's partly because marketing deals with opportunity and opportunities in the future, which you don't know. Even if machine learning were omniscient, nobody knows the future, much less a machine, okay? But this is the goal. The goal is probably unattainable, and that is what makes this so much fun. What marketing wants is big data AI predictive modeling. That is what the game is, okay? Magical thing. We want the Palantir stone, the crystal ball, to tell us the next action. That's the right thing to tell, to give to our customers. What's the next action prediction? And first, we should step back and say, what is your next action? What are you going to buy next week? Just tell me that. Tell me the next priority goal that isn't on your list of priority goals. And we also wanted to magically do the media placement, which, never mind. What does the CEO want, on the other hand? The CEO is different. The CEO wants known customer results, known return on investment, and scalable growth. How do I know? Because when I was in the agency, we pitched 5 accounts. 5 prospects came in, and every one of them we got 5 out of 5. That's like winning 5 Super Bowls in a row for an ad agency. And every one of them, the CEO or president said, I like this idea that you can do accountable advertising. And that was my part of the pitch. When we got done and the client came in, I never got invited to the kickoff meeting. Great snacks. I never got to come. Finally, I asked our creative director, why. He said, we want to win awards. We don't care about measurement per se. We hope there's good measurement, but we want to win awards. The ad manager wants to win awards. We don't want to see your ugly portfolio, even if you won every test you ever did. I quit. Anyway, what the CEO suspects is that AI will deliver customer insights. And automation will have a return on investment and there'll be scalable growth. That's why the CEO is after AI, even if the marketing people don't really know how to deliver on their promises or their expectations. Well, what are the challenges in machine learning? The computer sees patterns, but the computer sees spurious correlations. It's an absolute mathematical fact that the bigger your data set, the more correlations you'll have. I challenge you to look up spuriouscorrelations.com, I believe it is, or just search on spurious correlations. You'll find this hilarious website that finds a correlation between the swimming pool deaths per year and the millions of tons of oil shipped out of Norway. The more data you have, if you had pi stretched out to 1,000,000 digits and you had a random number generator, you would find long strings of correlated numbers, even though you know there's no earthly reason why. And that's what happens. The more data you have, the more spurious correlations, which is a huge challenge for machine learning, because when they start aiming at pictures or stop signs or facial recognition or words, the machine doesn't know. It finds similarities, but the similarities may have no meaning whatsoever compared to the way a human looks at it. And so what's required, and this is something, it's like, don't forget this. What's required is a labeled data set. What does that mean? Okay, if you remember Watson playing Jeopardy, okay, they used 120,000 Jeopardy question answer pairs. So they knew the right answers and the wrong answers, 120,000. And that's what they used to train Watson. What they had was a user-created labeled data set of right and wrong answers. And so that was key. Without that, they could never have played Jeopardy. Okay, what happens with Tesla? Well, Tesla is a really interesting case, because everybody, I used to watch videos of contests where they'd take vehicles out in the desert and map out what was essentially a road or a course and try to get the vehicles to go through the course without crashing. And it was terrible. And there were two main approaches. One approach was to try to teach the car what was a rock and what was a road, and to stay on the road. And the other approach was to give the car a map of the road and tell it to keep within these latitude, longitude waypoints. And the map of the road worked the best. The problem is the car couldn't recognize any changes in the road. So if you did that in the real world, you might drive off a bridge or go through a closed barrier. So Tesla took a different approach. Tesla said, let's load up the car with lots of sensors and let the person drive it, and we'll see how well we can understand what the person is doing. So Tesla let the users create a labeled data set of what's going on, and then they tried to correlate the two in an unassisted way. That's what machine learning is about. I met a guy who'd worked at IBM for 17 years on the Dragon Naturally Speaking voice recognition. And, I said, did it bother you that Google came along and in a couple of years just blew you guys away? He said, well, if we would have had that data set, we would have been able to do it too. How did Google do it? Google kept track. They did the best they could, and then they kept track of the corrections that people would make. So they let the humans label the data set. Okay? I went to some really great CIA, DARPA sites. It says, we're in an existential battle for truth in the digital domain. And this is the challenge we have. We've got a 15-mile-an-hour speed limit. 63% of the time we recognize it with our labeled data set once we've trained the computer. Pretty good. Now we go over and we put a sticker in it right here. We put a sticker, and all of a sudden it sees this as a 6 instead of, and 80% of the time it'll see that as a 65, which could be a problem if that's a school zone and your car is reading the signs. Here's a zoom in. It's a great video. It recognizes this stop sign, which is red, but the colors are flipped. And this one it recognizes as a person because there's a picture of a person on the background of the sign. And so it picks it up. But here it sees a car. Here it sees a car, which is a shadow of a truck. And here it sees a truck. And so that's pretty good. So the thing kind of works. Okay, so the way that AI works is right now we're hiring people, or we're getting users to, like Tesla, getting users to drive the car and not tell them that we're taking all the data. But it has to be trained. And it's trained with millions of hand-labeled images. They're trying to get computers to do the training of other computers. And they're getting, they can recognize fuzzy lines from straight lines and some other stuff. But according to DARPA, it's not there yet. And so the industry is going to grow, and they're paying them $2 an hour. But the greater the data set, the greater the spurious correlations. Thanks to the machine learning algorithms, the robot apocalypse was short-lived. That was surprisingly easy. How come robotic uprisings use spear and rocks instead of missiles and lasers? If you look at the historical data, the vast majority of battle winners used pre-modern weaponry. See, if you ask the wrong question, you get the wrong answer. So the computers were defeated because they didn't understand what a battle was. What they should have done is compared head-to-head which weapons defeated which other weapons, and then they would have been okay, because they would have seen a progression, or they wouldn't have seen it. Okay, if labeled data set is the foundation, what's the best way to build one? And that's what we're going to talk about tomorrow. I'm John Miglosh. Have a great day, and let's stop the stream.